All right, this probably feels kind of awesome today because you get to learn how to add. So today we're going to be working with adding rational numbers, which you might remember that's any number that can be written as a ratio of two integers. So they'll look like a fraction or a decimal or a whole number, um, or negative, that's fine. We're going to look at a couple properties first. They have some technical names that I would like you to learn, but they're probably going to be skills that you'll understand. So one is called the identity property of addition. I like to think about identity as who you are, something that doesn't change. Um, the identity property of addition says for every rational number n plus 0 always equals n, or 0 plus n always equals n. So I like to put that in nice human words. In other words, any number plus 0 is the original number. When you add 0 to a number, you get the same number. That's called the identity property of addition. A vocab word that I'd like you to learn is additive inverse. Additive inverse is another way to say the opposite of a number, the additive inverse. I have a question for you to think about before I tell you the answer. Okay. What will you get when you add a number and its additive inverse? So remember, additive inverse is the opposite of a number. So think about it. What are you going to get if you add a number plus its additive inverse plus its opposite? You should say that you get 0. This is called the additive inverse property, or the inverse property of addition. So for every rational number n, there's another number called its additive inverse, negative n, such that n plus negative n always equals 0. So in other words, in your vocab, if you add a number and its opposite, you will always get 0. So the inverse property of addition, it just says if you add a number plus its opposite, you always get 0. Okay, good thing to know. You probably already knew that. Okay, so we're going to work on some examples where you have to use your rules and what you've learned in the past. And you have done this before, but some of you need a refresher on it. So I want you to think about adding negative 6 plus 8 by using a number line. So I'm going to pull out like a little number line. I'll do this up at the top. So here's my line. And I'm going to add negative 6 plus 8 using this number line. So I'm going to call this 0 on my number line. In negative 6, I don't usually draw all my numbers out. I just say negative 6, that's going this way to negative 6. If I add 8, then I need to go to the right 8 spaces. So I add 8 here, add positive 8, going positive. I have to think, where am I going to end up? Okay, so I went 6 to the left, 8 to the right. I'm going to end up at 2. So negative 6 plus 8, that's positive 2 using a number line. Negative 4 plus negative 5 this time. So I'm thinking of the same type of rule. I really like you to visualize this number line. I'll draw it down here this time. Okay, so negative 4 plus negative 5. If I look at this, okay, I always start at 0. So to get to negative 4, I'm going left 4, so to get to negative 4. Now I have to add negative 5, so when I add negative 5, I'm going even deeper into the negatives. Negative 5 more, so you have to think, where am I ending up now? I went 4 to the left and I went 5 more to the left. I ended up at negative 9. Okay, so negative 9 is my answer to negative 4 plus negative 5. Sometimes problems are a little tricky to use a number line. At least really easily, but I like to use my number line ideas to help me think about what's going to happen. So C, let's try this one, 3.6 plus negative 7.1. So again, if I'm looking at like a number line idea, so I've got my line here, and I start at 0, and I'm going 3.6, so I'm going to start over here at 3.6, and then I'm going to go negative 7.1, so 7.1 to the left. What I like you to think about is what's going to happen. So are you going to be in the positives or negatives? I hope you say I'm going to be a negative answer because I'm going further to the left than I did to the right. And what am I doing to 3.6 and 7.1 to kind of find out how far I'm going to be negative? Well, if you think of those as positive numbers, you would be allowed just to subtract them as positive numbers, but just be smart when you subtract. I'll do this on the left. I'm going to do 7.1 minus 3.6. Don't forget, like, use your borrowing skills. You won't be allowed to use a calculator on most of this unit. 11 minus 6 is 5. 6 minus 3 is 3. So 3.5 is like the difference between 7.1 and 3.6. So the difference between the directions I pulled. But remember, I pulled further to the left, further negatives. So my answer is going to be negative 3.5. Okay, let's look at one more problem. This I have negative 514 plus negative 843. So again, if I'm just kind of thinking about what's going to happen on the number line, sorry for that bad number line, but if I start at 0, I'm going to go negative 514 and then negative 843 more. So this time they're both pulling in the same direction. They're both going to the left. So I'm just going to add them like normal because I'm going to add because they're both going the same way. So 514 plus 843 just adds straight up. I'm going to get a number of 1357, but remember I pulled all the way into the negatives. So my answer for this problem, I should be at negative 1357. Okay, so I like you to think about your number line so that it can help you visualize your rules and where your sign should be. And you won't be able to use a calculator, so I want you to be able to do all this stuff just straight out. Okay, let's look at a few more examples. Okay, so this one, it can tend to be a little tricky for some people. It has a variable in there. It says evaluate negative 3.6 plus negative n. That's just in parentheses so that the plus and minus aren't right by each other. Don't panic about the parentheses there. For n equals negative 1.7. Okay, so you're going to be careful here when you're substituting it in. You're going to do negative 3.6 plus, it says negative n, so that's negative 1.7. Okay, so a negative negative, remember, like when you take the opposite of a negative, you're going to get a positive. So I might just ignore this negative negative or turn it into a plus. It might help you out there. So my new problem, what I'm really doing, I'm doing negative 3.6 plus 1.7. So if I think about my number line again, I'm going to be going, if I start at 0, I'd be going left negative 3.6 and then back 1.7. So I should still be in the negatives, but not as far. So if I think about that, I want to subtract 3.6 minus 1.7. Don't forget to borrow. So I'm going to do 16 minus 7 is 9. 2 minus 1 is 1. I've got 1.9, but look, I'm in the negatives here. So my answer should be negative 1.9. Okay, let's look at a little word problem. A scuba diver who is 88 feet below sea level begins to ascend to the surface. So he's like here, there's the water. He's down here 88 feet. So he's at like negative 88 below the sea level. I want you to write an expression, an algebraic expression, to represent the diver's depth below sea level after rising any number of feet. So right now he's at negative 88, and we can call like n the number of feet he rises, because I'm going to need something that represents any number of feet. Okay, so think about if you can solve that on your own. But what's going on here? It starts at negative 88, and he is adding, because he's going up n feet. So this is an expression. We don't need an equal sign. I'm not writing an equation. That would be his depth below sea level now. He was at negative 88 plus n. Okay. If I find the new depth of the scuba diver after rising 37 feet, that means 37 is my number of feet, so n, and I'm going to do negative 88 plus 37. So think about what that's going to happen again. It's kind of big numbers for thinking about a number line, but remember I go left 88, right 37. So I'm pulling in opposite directions, so I'm going to subtract these. And I get that I'm going 51 feet somewhere. Since I pulled further left than right, I'm going to be at negative 51 feet. So he is 51 feet below sea level. Would be a good answer for a word problem. I'll go ahead and circle that. He's 51 feet below sea level. Okay, you're going to get to see kind of something new in this unit called matrices. And matrices look scary, but we're just adding them, so it's nothing to be afraid of. A matrix is just a rectangular arrangement of numbers that are in rows and columns. Here's an example of a matrix. This might be a place that can show enrollment in these different schools. public versus private. Okay, so if we're looking here, in elementary schools, the enrollment is 29.8, probably millions. Private school, 3.4. And you can see the same high school, college. This is a matrix. It's a rectangular array. Just has some rows and columns. When you call matrices, when you name them by your size, you call them rows first, then columns. So this matrix above, it has 3 rows. You can see 1, 2, 3, and 2 columns, 1, 2. So we call it a 3 by 2 matrix. Each item in a matrix is called an element. So like this 29.8, that's an element. The 1.2, that's an element. When we add matrices, you can only add matrices if they're the same size. So like if you have a 3 by 2 matrix, the other matrix has to be a 3 by 2 matrix if you're going to add them. But all you have to do is add them by adding corresponding elements. Your answer is not just going to be a number, it's going to be a matrix. So we're going to look here at these 2 matrices and we're going to add them by adding corresponding elements. So you might notice that this first matrix has 2 rows and 3 columns, so it's a 2 by 3 matrix. The second matrix, it also has 2 rows and 3 columns. It's a 2 by 3 matrix. These are the same size, so I'm allowed to add them. Okay, if they're not the same size, I couldn't add them. My answer is also going to be a matrix that's a 2 by 3 matrix. So it's going to look something like this. And to figure out the just like what's going on here, we're going to look at elements that are in the same location. So to find my answer in the top left of my matrix, I'm going to add -6 and +7. They're both there. For the next one, I'm going to add 8.6 and -5.4. I'm going to see I can add 11 and 2, etc. I'm going to add 2.3 and 11.1. So you can kind of get the pattern that I'm doing here. Let me see if I can get you another color. Let's see if I got that. There we go. And then we'll call the last one blank. So I think that can work out. So here we go. I'm going to add -6 and 7. That's going to be my first answer. And that's going to be a +1. So that's going to go up here in my left, top left. Then I'm going to add 8.6 and -5.4. You might have to think about that a little. So you're pulling 8.6 to the right, 5.4 to the left. If you need to go ahead and show your subtraction problem straight down, you can, but you don't need to borrow in this case, so it might not be as bad. The 8.6 is positive. It's pulling you further, so this is going to be +3.2. I'm just going to add 11 and 2. That's not bad. It's just 13. 2.3 and 11.1, those are also both positive, so you should just be able to add. If you need to line up your decimals and show it, that's fine. So if you want to go 2.3, 11.1, totally fine. You can also do this in your head. I'm going to be okay either way. This is a 13.4. 5 and 3, hey look, those are also positive, not bad, that's an 8. And then the last two, -3 and -1, both pulling in the same direction this time to the left of 0, so it's going to be -4. This is my final answer. It's going to be a matrix, and it's also going to be a 2 by 3 matrix. Okay, so just a short guideline today. I want you to do your own homework with no calculator and just see if you can remember your rules, think about a number line, visualize, and do your best. Okay, good luck. I'll see you tomorrow.